In this example, we're going to look at solving trig equations by taking square roots. So we're going to solve them basically the same way as before, but before we do it, I'm going to break this down into a more simple problem. So imagine we had 4y squared plus 1 is equal to 4. And I asked you to solve for y. You would get 4y squared is equal to 3, y squared is equal to 3/4, and y is equal to plus or minus radical 3 over radical 4, which is plus or minus radical 3 over 2. This is the old Algebra 1 version of this problem. We're going to follow those same exact steps, but now we're going to involve sign instead of y. So step 1, I subtract 1 from both sides. I get 4 sine squared of x is equal to 3. Then I'm going to divide both sides by 4. And I get sine squared is equal to 3/4. So then I take the square root of both sides. And I get sine of x is equal to plus or minus the square root of 3 over 4. And using square root properties, we can get plus or minus radical 3 over radical 4, which is plus or minus radical 3 divided by 2. So this really now breaks down into two problems. It's going to break down into sine of x is equal to radical 3 over 2, and sine of x is equal to negative radical 3 over 2. So all we have to do now is go ahead and solve this problem. So where is sine of x equal to radical 3 over 2? It's equal to radical 3 over 2 at pi over 3 and 2 pi over 3. And sine of x is equal to negative radical 3 over 2 at 4 pi over 3 and 5 pi over 3. And so now we just have to write our final answer, which is going to be x is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And then for all of these, plus 2 pi n, because there's an infinite amount of solutions where n comes from the integers. If you want to write every single one with a plus 2 pi n, that's okay. And it would look something like this. However, if you do not, you can write it the first way as long as you have this plus 2 pi n where n is an integer. All right, on your own, I want you to try to solve this equation. So give it a shot. All right, so first step, we subtract 4 from both sides. We get 3 cotangent squared of x is equal to 3. Then we're going to divide both sides by 3. So we get cotangent squared of x is equal to 1. And then we need to square root both sides. So we get cotangent of x is equal to plus or minus 1. So this becomes two problems now. Cotangent of x is equal to 1. And cotangent of x is equal to negative 1. The only two places where cotangent is equal to 1 is going to be pi over 4 and 5 pi over 4. And the two places where cotangent equals negative 1 is going to be 3 pi over 4 and 7 pi over 4. So the last step is to take all of these and add pi n. And we add pi n because this is the period of cotangent. And we have to say n is in the integers.